topic is Bessel function. So, there are uh, differential equations. We have already done the first order differential equation, the second order differential equation, and we can actually solve them. Okay, and there is certain pattern of differential equation which is very common. Okay, and they are named after someone or someone who has actually worked on it. So Bessel actually worked on this function, and this function in his honor has been named as Bessel function. Okay, I'll just give you the form of that function first. Okay, and we have already started with the chapter, and we are actually discussing differential equation in this chapter, right? So if we do the same, continue with this, we are going to actually discuss differential equation only, but now we are going to just consider some specific forms of differential equation. So one of the initial forms that we should know is Bessel function. We are going to deal with four in this particular set of lectures. So x square, if you have an equation of this form, x square d2y dx square, so it's a second order differential equation, straight away we can say, plus x dy dx, y is the function that we have, plus x square minus m square, m is any variable we have, into y is equal to 0. If we have any equation, differential equation of this form, it is actually called Bessel function, and it's basically a standard function. Okay, so it's something which we are going to deal with. Okay, so this is actually a differential equation, so we can actually call it as Bessel's differential. Yeah. Anyone has any doubts? Am I audible, by the way? Voice is
Yes,
clear,
sir.
right?
Yes, sir.
Okay.
Yes, sir.
So it is called the Bessel differential equation. So that means we are continuing with differential equation. We are trying to just look into a specific form of the same. And such differential equation, which is actually written in in the second order, we can actually solve them, and we can actually get a solution of this. So the general solution of Bessel equation, more specifically differential equation, is y. We are going to solve it for y is equal to a, and there is something which is called the Bessel function, as I said with the heading, a j n x plus b k of minus n x. So there are certain things that you need to remember here. These are nothing but the recurrence relation. But before we actually remember the recurrence relation, we will try to derive the recurrence relation. Okay, so this is the general solution, and if we just more specifically look into it, we are going to have some form of Jn and a minus n. Okay? So that's very important. So probably this slide is very important. So let me just write down what is the form of Jn and Jnx. So where we can write down Jn of x is equal to summation r is equal to 0 to infinity, and we can just write it down as minus 1 to the power r, okay, divided by factorial r. Please remember these, okay, this is very important. uh, we are having so many problems to solve that I don't prefer solving this and finding out this form. We're not going to include this. We're just going to remember the form, and Bessel function, remembering the form is important. Even if you're giving any entrance exams and all, these forms will actually help you out to solve all the problems. That's the one. So if you look into the original equation, there are terms here, okay, and r is it's nothing but the summation term that we have. R starts from 0 to infinity, okay, and here this is the form of j and x, okay, and in a similar way we can also write down what is the form of j of minus nx, okay, that's summation 0 to infinity, and then everything will remain more or less the same. Only in case of n we have got minus n, so this is minus 1 to the power r, and then divided by factorial r, and then we have got the gamma here, okay, but you will eventually see that this will actually remain as minus n, okay, so this is n plus r plus 1, okay, and this would be nothing but x divided by 2, and in case of n, we have got minus n actually here. So this is the form of Jn and Jn of j of minus n of x. Okay, so this is something which is there. Apart from that, certain things that I hope you remember. Okay, just write down, factorial r. Can actually write it down as r into factorial of r minus 1, right? So these are some notes which you should remember. You can recall the gamma function and all, okay? Or in general, let's say everything factorial 5, you can write it down as 4 factorial 5, right? You can also denote factorial 5 by this, okay? Sorry, 5 factorial 4. So these things we already know. 5 factorial 4, so just reduce by 1 to that. Okay. So we are going to use such terms, okay? We have something like, let's say, gamma of n plus 1, we can write it down as n gamma n. So this one is also something which you might remember. Okay, if we have something like gamma 6, we can write it down as 5 gamma 5. Okay, 5 plus 1, so I can, ignore that 1 and then take out the 5 and then 5 gamma 5. So that's how we actually remember these. Okay, so these things we have to remember as a node. And based on this, we are going to derive something which are actually called the recurrence relation. So for recurrence relation, what you need to remember is, okay, whatever recurrence relation we are going to talk about, we have to remember this. This is very important. Okay, I would suggest all of you try to remember this. Okay, at this point of time, you will see that we are going to use it for this class, and you need to remember. Okay? So what we're going to do now is actually recurrence relation for uh, J and X. Okay, so we'll write down the heading here, and the heading is recurrence relation uh, for J and X. So this is something which we are going to do now. Okay, recurrence relation for J and X. So there are 5 recurrence relation that I'm going to discuss. Okay, let's start with the first one. So it's just normal, maths, some tips and tricks. You have to do certain adjustments, and then based on that, you can actually get the recurrence relation. So the first recurrence relation that I'd like to discuss is this: e dx of x to the power n. So this is something which is derived from Bessel function. So that's why it is under Bessel function. E dx of x to the power n, j, and x is equal to x to the power n, j, and minus 1. Now these are important. If you look into entrance exam, you'll probably get a question on what is the recurrence relation, which one is the correct recurrence relation. And if you talk about the normal exams that we are conducting, class exams or end semester exams, you have to know how to prove it. Okay, so that's very important. So that's why I need to just practice. Okay, that's important. Okay, just give me a minute. So we have to prove this relation. Okay. So I prefer not going too fast, because what I want is all of you should write it at the same time as I'm writing this. Okay? Because else you'll miss out a lot of things. Okay. So I'll just try to do it a bit slow so that you can actually follow and also write it at the same time. Just looking into it won't serve the purpose. Okay, it's very difficult. So I have to write down DDFs of x to the power n dx. So obviously I'll start from what is my JN. So what I'm going to write down first is the form of, right? So the form of JNX that I have, that we all have seen already on this left hand side, summation r is equal to 0 to infinity. and then this is minus 1 to the power r, okay, divided by factorial r, and then we have got gamma n plus r plus 1. We have this, and then I have that as x divided by 2 and plus 2. So obviously we are going to solve this. We need to have a starting point, and this is our starting point. Okay? And then it's multiplied with x to the power n. So what we can do is we can multiply both sides with x to the power n. I prefer all of you writing down after every line that if you are doing any steps. So on this side you can write multiplying both sides by x to the power n in your exam. Right now I'm not doing it because we have to solve so many things. But the more detailed the better. So r is equal to 0 to infinity, and then this remains as minus 1 to the power r. And don't skip steps in these kind of problems because it needs to be detailed, otherwise you are going to miss the main concept. You have to be very careful while solving this because can make mistakes. Okay, so n plus r plus 1, and this is x, okay, and you have x to the power n here. You also have got x to the power n plus 2r, so that one x to the power n you can combine. So you will get x to the power 2n plus 2r because you are multiplying both sides by x to the power, and at the denominator it will remain as 2 to the power n plus 2. So in do it, we have to just look into the left hand side and check what we need to solve. That means what we have to do now is find out the differential of this. Okay. So let's just try to find out the differential. So what we can do is we can just take ddx. Okay, I'm going to do this one. I can do it directly. I think x to the power n j n x. So left hand side I've done. I have to just add the right hand side in such a way so that I'm going to get it as per the question. So this is there. Okay, and let's just take out whatever is not needed to differentiate. So r is equal to 0 to infinity. This is minus 1 to the power r divided by factorial r to gamma n plus r plus 1. Okay, we have it here. And then we can differentiate this. So ddx of this, so that means next to the power n minus 1. So you can simply write it down as 2n plus 2r x to the power 2n plus 2r minus 1, right? And x to the power n minus 1 divided by n plus 2r. So 2 to the power.
Hello, sir.
Yeah.
Sir, in solution, the second line, there's an x to the power 2n plus 2r. How x to the power 2n come? Because there is an x to the power n
Because
plus
if you
2r.
look into the question, this is multiplied by x to the power n. So we are multiplying this side by x to the power n. On
Yes,
this
sir.
side also we have to multiply by x to the power n.
Oh,
So
you're
let me multiply both sides by x to the power n. It is x to the power n plus 2r, right?
yes,
So
yes,
if
yes.
I take an x to the power n, it will be x to the power 2n plus 2r. Is there?
X to the power 2n. Okay, sorry, I write this.
This is only n.
Okay, sir. Okay,
2
understand.
will come when I multiply it with x to the power n on both sides. Correct?
Okay, sir.
This is exactly the point because when we do it, and that's why I'm also not skipping steps. Okay, so you have to be careful. And you understand each and every line, very important. Okay? Because there are 5 relations. Just started with the first one, and when all 5 are done, you see that all of us will get confused. Okay, so we have to be very careful. Okay? So that's why I am taking it slow. I need time to solve these problems, and that's why we're taking longer classes for this stuff. So this is there. Okay? And let me just copy this so that we are clear in the next slide. So we have stuff to just right, conclude. Okay. So we're solving it. Let's keep solving. Let's see where we reach and how we reach the final answer. Okay. So we have this, and let's go to the next line. So you see, we have to, the right hand side, we have to write it in terms of j in minus 1x. So that means we need to involve n minus 1 there. Okay. So let's try this. Okay. So just concentrate on the right hand side now. Left hand side is done. R is equal to 0 to infinity. I can take this is minus 1 to the power r. Here I can take 2 common. So I'll take 2 common and I can write it down as n plus r. And then we can write it down as x to the power 2n plus 2r minus 1 divided by this is as it is 2n, sorry, yeah, this is n plus 2r, n plus 2r. And here what you can do is this will remain as factorial, not an issue. But then this one, it is gamma of n plus r plus 1. So I told you the property here. I can simply write it down as n plus r gamma of plus r. That's the property of gamma function. Not that I need in your undergraduation honors course. So what we can do is we can just cancel this out. So I'll just have divided by gamma n plus r. As you go to the previous section, you have to show that this is jn minus 1. So what's my jn? Check this. This is my jn, right? So that means if I want to have it as n minus 1, in case of n, it should be n minus 1. We have an n minus 1 here, and nothing to do with r. That needs to be noted. It is n minus 1 on this side. There also we have n minus 1. Okay, so that means we have to write down a equation in such a way that on the terms where we have n, it should be n minus 1. So let's continue with this and just we'll explore the first one. It's important because we need to look into the steps. Every recurrence relation will have different steps to solve, so that's very important. So again, I'll go back to the previous slide, right? See, this side it should be x star n jn minus 1 x. So here, do we have any x to the power n? After this, yes, we have an x to the power n here. So let's take out that x to the power n and separate it out. Okay. So if we do that, what we can do is this. We take one x to the power n out. Okay, we could have done it beginning, but I think we can do it here also. Same thing. X to the power n. So I'll just write down x to the power n here. And then what we do is this. Summation r is equal to 0 to infinity minus 1 to the power r, okay, divided by factorial r, no changes here, into x to the power, this is 2n plus r, 2r minus 1, 1 x to the power n I've taken out. So I'll just write it down as n minus 1 plus 2r. I hope you understand this. N minus n plus 2r divided by, now this is 2 factor gamma n, sorry, is already there, gamma n plus r 2 to the power n plus 2r, and then there is a 2 here, don't miss this out, this comes down, so it is taken as minus s1. So every step, every variable has a lot of importance. We have to take care that we don't make that any kind of mistake. Okay. So next, what we do is formula there, okay, is equal to x to the power n there, then summation r is equal to 0 to infinity. I'll keep this as minus 1 to the power r divided by factorial r, and then I need n minus 1 on this side. So that means in place of n, I should have n minus 1. So what I will do is I will write down this as n minus 1 plus r, but then there is a minus 1 extra which is not there. So I will just add plus 1. Okay. And then I have this, the n minus 1 plus 2r, this is also n minus 1 plus 2r. So that I can simply write it down as x divided by 2 n minus 1 plus 2r. If you compare and have a look, this would be nothing but x to the power a n minus 1. That's the proof. Let me just write down jnx once. So what is my jnx? Jnx is equal to 2 is done now. R is equal to 0 to infinity minus 1 to the power r divided by factorial r gamma of n plus r plus 1 into x divided by 2 into n plus 2r. That's my j and x. Now let me just mark this. In place of n, we have got n minus 1. In place of n, we have n minus 1. That means this term is jn minus 1x. What about r? R is here, it's here, same. R is here, R here, it's same. R is here, R is here, it's same. There is a 1, there is a 1, no problem. X by 2, X by 2, no problem. 2R, 2R, no problem. Everything else remains same, only we have n minus 1, n replaced with n minus 1. So when you solve this recurrence relation, you should be very careful that you remember the correct form of j and x and write down your final equation in such a form whichever is demanded by the question. Okay? So that's the first recurrent relation. So we need to remember, these recurrent relations as well. That's the tragedy of this particular topic. We need to remember. But if you know the main form and practice it once or twice, have a look at it every now and then, you will basically remember it. It's not very difficult. Okay, so this is the first recurrence relation. That means if there is a first recurrence relation, there should be second recurrence relation as well. And I'll give you a total here. We have got 5 recurrence relations. It's very important from your examination point of view and test point of view and everything else. So we are going to discuss 5 recurrence relations, out of which 3 you are going to derive. It's going to be very long. Okay? But then the other 2, you can easily do it if you remember the first and the second recurrence relation. Having said that, let's just do the second recurrence relation now. Okay? So number 2. The second one is p dx. Please note everything very carefully, and I am doing it slowly. Okay? It helps me keep my handwriting okay on the screen. At the same time, we will also get some time to write it down. Think and act, okay? Don't just copy. That is something which I would suggest. Minus x to the power minus n k n plus 1 x. This is the second recurrence relation. Okay, this is so. So similarly, we are going to follow, and every time we start, we are going to start with j and x. And what I prefer is keep writing that j and x so that at the end of the day you remember minus 1 to the power r divided by factorial r gamma n plus r plus. So it comes under solving numerics, okay? Using Bessel function to find out some forms. It's a full recurrence relation, but there are nothing, algebraic adjustments to get a particular form. So to start from there, you are going to take x to the power minus n now, because on the left hand side we have got x to the power minus n k n x is equal to summation. Take care of this step, this is very important. We are taking minus n, so we are mixing it up with x to the power n plus 2r. So minus 1 to the power r divided by factorial r gamma n plus r plus 1 into x to the power n plus r multiplied with x to the power minus n. We are just going to get x to the power, that's it, divided by 2 doesn't change, 2 to the power n plus 2r. Yes, this is done. What we do now is to take a dx on both sides. So we take d dx of x to the power minus n j n x is equal to summation r equal to 0 to infinity, and then this is minus 1 to the power r. I'm not going to change anything here. Factorial r gamma n plus r plus 1. Right. plus r 1 2. This is x to the power 2r, so this the dx of this will be nothing but 2r into x to the power 2 1 divided by to the power n plus 2. Keep working on this. Summation r is equal to 0 infinity minus 1 to the power r divided by factorial r. Okay. Now here what we are going to do is we are going to do certain modifications. This factorial r, we have got a 2r on top, which we don't need because that is not there in the recurrence relation. We can just simply write it down as r into factorial r minus 1. Okay. And this gamma, this is r minus 1 is there. So that means can we have an r minus 1 here also? The answer is yes, right? What we can take is we can write down something as n plus 1. Just take care, okay? N plus 1 because anyway we need n plus 1 here. Then plus I need r minus 1, so this will be r minus 1. I'll just write it down as r minus 1 plus 1. It's all about adjustments. And on top we have got 2 into one more step, I guess. 2r into r to the power or x to the power 2r minus 1, and in this time 2 to the power n plus. Take a look at this step again. Okay, I've written r factorial r is r into factorial r minus 1 near the property. Then n plus r plus 1 can be written as n plus 1 plus r minus plus 1. This is quite obvious because we finally want to get n plus, we want to keep it as n plus 1. And there is an r minus 1 here, so this should also be r minus 1. So we can just cancel this out, and we can cancel this out. Okay. And then we can actually go to the next step. So in the next step, what we do is we can take out 1 minus n common. Okay, so this is to the power 2r. We have got x to the power minus n. Okay. So we can just step here. Let me just check here. So what we can do is idea next to the minus n, so I've just taken it out. That's it. And then I can take a summation here. This is minus 1 to the power r. I will go to 0 to infinity. That's the same. The bottom we have got factorial r minus 1. And then we have got gamma n plus 1 plus r minus 1 plus 1 into, and then we can actually have it as x if that is equal to, and we have written minus n, so we should also have a plus n something. So x can have a value of plus n here, that is minus x to the power n minus n will get cancelled. On this side we actually have two more terms, which is 2r plus 1 minus 1, so we can just put plus 2r minus 1. At the bottom we have got n plus 2r, but then there is a 2 here, so this will come at the bottom. So we are going to get the same term. So this is n plus 2r minus. Okay, we have this now, and then this is almost done. This is x to the power n r is equal to 0 infinity. Okay. We are actually going to have it something like this. So you see, I can put a minus 1 here, and if I have a minus 1, I can multiply it with again minus 1. Plus minus will become plus. So I'm going to get the same thing. Okay. So this is minus of x to the power n, and then this is minus 1 into minus 1 to the power r already there, divided by factorial r minus 1 comma n plus n plus 1 into plus of r minus 1 plus 1 into x divided by 2. In case of n, I need n plus 1, so just put n plus 1 directly. Then, if you look into the original recurrence relation, there is no such thing as minus 1, it's just n plus 2r. So in place of n, I'll put n plus 1, and then I'm going to just write it down as 2 times r minus 1. So you just open the bracket, you're going to get the same thing. Check this. N plus 1 plus 2r minus 2, so 1 minus 2 is minus 1. So you're going to get the same thing. What we have here is this. If I just, I'm not going to write down these lines again and again. So maybe I can just scrub this off. Okay, power is the same. Yeah. Okay, whether you take n r plus 1 or minus 1, you're going to get the same result. Minus 1, you're going to get it as divided by minus 1, right? It's going to be the same result. So write down plus 1 here, r minus 1, you're going to get a minus sign. So that's the same thing. Check this. And if I check it here, you see, in place of r, I've got r minus 1, r minus 1, r minus 1, r minus 1. In place of n, I have got n plus 1 and n plus 1. So when you write in the recurrence relation, r, whether it is r minus 1 or only r or r minus 2, doesn't matter. The only thing is everywhere it should be r minus 1 or only r. That's fine. So that means if I do it, I can simply write it down as minus x to the power n and k n plus 1. So that's the proof of second recurrence relation. So I will keep this on board for that is important. Consistency is important, but that doesn't define how J is written. So that is very important. So let's check the third relation. Okay, and the third relation is this x J n dash x is equal to n J n x minus x J n plus 1 into x. So we are going to prove this now. So there are three terms here. So let's just take the left hand side and check. So let's try to solve this one. So we have got j and x. So obviously we're going to start from this relation is equal to summation r is equal to 0 to infinity, and this is minus 1 to the power r divided by factorial r gamma n plus r plus 1 into x divided by 2 n plus 2r. So that's my relation, and we're going to do it. So if it's j dash, means we are just going to take ddx of that. Okay, it's not ddx of x and j and dash x, it is just j dash. So let's just find out j dash first. So j dash n x. So whenever it is written in that way, that means we are just going to differentiate it with respect to x. That's it. So I'll take the steps here. R is equal to 0 to infinity. This is minus 1 to the power r divided by factorial r gamma n plus r plus 1 into, okay, and then this is n plus 2r and x to the power n plus 2r minus 1 divided by 2 to the power n plus r. Okay, so that's my relation. Let's just try to combine things here. Okay? Keep it simple. See, I have got two terms here, n j n x and x into j n plus 1x on this side. Okay, so before we really do it, what we can do is this. I'll multiply both sides with x and see what is something which you're getting. Okay, so check this. So this is x j n dash x. So now what I have is this summation r is equal to 0 to infinity minus 1 to the power r. So you'll keep writing these things again and again. No other option. So n plus r plus 1, 5. This is n plus 2r. So I will keep this here, n plus 2r, And then we have got x to the power n plus 2r minus 1, and I have multiplied by x on this side, so that means this side also I should multiply. So it will be x into x to the power n plus 2r minus 1, that's n minus 1, don't get confused, divided by 2 to the power n plus 2r. So power is 1, so I can just add 1 here. So that means, I can just get rid of this x here, and I can get rid of this minus here. So this will actually remain as, so this is something I'm taking advantage of. I can grab and write it again. You have to write down the next step. And then, this is n plus 2r, this is also n plus 2r, that means I can write it down as x by 2 to the power n plus 2r, right? But we need n and other terms separate, so we are going to separate this from here. So this is n plus 2r, right? So let's just write down two terms here. The first term would be summation r is equal to 0 to infinity. This is n here. We have this n, so maybe we can write down this n here. And what is left out is minus 1 to the power r into divided by factorial r into gamma n plus r plus 1 into this is x divided by 2 n plus 2. This is first term. The second term would be plus, and what we have is this. So in the second term, we actually need an x here. So we are going to use that modification also. Let's do it. I'm also going a bit slow because if I do it fast, if I miss a step, then it's very difficult to debug. Cannot get back the steps which I missed out. So I don't want to rush. Factorial r gamma of n plus r plus 1. Written one term. And then what are we left out with is here. Let's just check. We are left out with 2r. So maybe we can write down this 2r. And I missed out anything. It's fine. Okay, and there is a factorial r here. So factorial r here, let me just write it down as r into factorial r minus 1. All of you know I have done this, instead of this. And then I can write it down as gamma n plus r plus. Let me just write down, remember the original expression so that we don't make mistakes there. So what is left out here is to the power n plus 2r divided by 2 to the power n plus. And here what we have is this x to the power n plus 2r. We need an x here. That means we can multiply with x and then divide it with x. So I can write it down x into x to the power minus 1 so that we are not hampering the original relation. So the first term can be written as n into j n x. Just note down everything, don't miss. Thus, I take out one x outside, so I take this x outside, so I take this x here, and then summation minus 1 to the power r divided by, so sorry, I've written this two times, sorry. Just once, I can two times. So this is r into r minus 1, so this r and this r will get cancelled, and I'll have at the denominator factorial r minus 1 into gamma n plus r plus 1. And and then we have got x to the power n plus 2r. One x are taken out and left out with this x. So I can write it down as x to the power n plus 2r minus 1 divided by, this is again, this is 2, this is there. So I can again write it down as 2 to the power n plus 2r. So we have this. So just one final step here. N a n x is equal to, so plus, right? So plus I can write down, okay. All I can do is I can write down a minus here. Just like we did it in the previous step, I can write it down as minus x. R is equal to 0 to infinity. In place of minus 1 to the power r, I just subtract it as minus 1 to the power r minus 1. If I do it that way, I'm going to get a minus here. So that minus will actually make plus again. So not changing anything. It's just r minus 1 gamma. Right. I need n plus 1 on this side. So this is also something which we did in the last step. There is n plus 1 plus r minus 1 plus 1. So nothing is changing here. In place of r, we have got r minus 1 into x to the power n plus 2r minus 1 divided by theta. So, we need n plus 1. So I'll take x by 2. I'll write the power as n plus 1 plus 2 times r minus 1. Lack of space, but please note, if you expand this, we are going to get back the same. So this is nothing but n a n x minus x, and this is j of n plus 1, j of n 1 proved. This is my third recurrence relation. Third recurrence relation. You see, we have done 3 recurrence relation, and 3 of them you have to practice it once or twice, and then probably can remember this better. It'll take some time. Without practice, it's not possible. So this moment, if you're just looking into it and not practicing, the chances are you won't remember it. But if you look into it and practice on your own, you are going to do it easily. Not going to be very difficult. Okay. But this is not something which is not conventional. Okay, you are doing so many sums, you'll get confused sometimes. So you have to just not practice it once. Practice sometimes without just looking into it. Okay, let me give you 2 more recurrence relation. Okay, actually there are 6 recurrence relation. Okay, so I'll take the 4th one also. I think this one also we can do, and then the 5th and the 6th is very easy. The 4th one, the 4th recurrence relation. So the 4th recurrence relation is this: x j n dash x is equal to minus n j n dash x plus x j n minus 1. Now this is a relation which is something which is similar to the previous one. At least the initial few steps are the same. Okay, and if you remember the previous relation, let me just write it down. Obviously you can't remember. I don't expect that. When I can remember it once, it's very difficult. It takes time to get adjusted to keep practicing. So I will copy this and put it in the next slide. Okay, copy and then just paste it. So look into this particular relation, the third recurrence relation, and we have already derived it. Try to derive the 4th one. So the steps are more or less similar. You see, there is n j n x. This is minus n j n x. This is x j n plus 1 x. This is x j n minus 1 x. So if there is some kind of symmetry to it, try solving it. Okay, and let me give you around 10-15 minutes. Let me give you 15 minutes here. You can just use similar steps and try to solve it. Okay, and solve it, and then we will discuss. I'm just going off test for around 10 minutes. Okay, but then this is important. Try solving it on your own, because you got the technique here, but the logic already written what is J and X. Okay. Try doing it. Okay, just put my mind. It's going to be simple. I'm just going to do a few steps only so that get the hang of it. So you have to just find out what is J n dash X. And when you do it, do it slowly so that there is no doubts and no mistakes.
Hello, sir. Got it.
Got it? That's good. Okay. So I don't know what is your mindset, but for me, first is very important is accuracy when we're doing these kind of sums. Okay, here, speed doesn't really matter because these questions are never going to come for entrance exam. No one is going to ask you to prove it. It's obvious. But then for your final exams, you can be rest assured that out of these 5 or 6 recurrence relation, one question, two question might definitely be there. That's very important. But for your entrance examination point of view, you should remember the result. I'll tell you why. Because there are some numericals which we'll be doing. Probably not today in the next class, and there we'll be actually using them. So that's that. Okay. So we just do DX of this, and then we can do similarly TX, JL dash X. Okay, and when you do it, we just get rid of this. Okay, maybe I can do it here only. So when you multiply it with X, we will just rid of this stuff. So something that's vanished here. Okay, and you need a minus n. Okay, so you can do your adjustments accordingly. Okay, it's very simple. Take for maybe I will again do it here itself. Okay, so we need a minus n. So what you can do is here directly. Don't do it my way. Okay, no problem. But minus n plus n minus n plus 2n. You can do it. Okay, but then all line and multiply. So originally we had actually n plus 2r. So in place of n plus 2r, I can write it down minus n plus 2n. So that will give me n plus 2r. So you see you have got a minus n here. So what you can do is you can take out that minus n and separate out everything. This will be minus 1 to the power r divided by factorial r gamma of n plus r plus 1. I hope all of you have reached a stage so that I can do it a bit fast. So this will be x to the power n plus 2r divided by 2 to the power n plus 2r, right? And this is quite obvious. This is JNX, and I got a minus n also. Okay, plus then I can take that plus x minus x thing. Okay, and do it accordingly. So what I will do is I will take out 1x outside, and I will do it in short. I'll just keep this minus 1 to the power r, and then this will be 2n plus 2r. So I can write it down as n plus r into 2. So this is there divided by factorial r gamma n plus r plus 1 can be written as
n
n
plus
plus
r
r.
into gamma n.
Mhm.
Sir, n plus r into gamma n plus r.
Yes, correct. Okay. That's it. N plus r plus I have got, yeah, sorry. Okay, this is gamma n plus r plus 1. This
Sir,
is n
n
plus r
gamma n
plus 1.
plus r, sir.
N plus r. There should not be a plus that, correct? I think we also have done these gamma functions. The gamma functions is a very important. This is nothing but something that is getting simply done. Then we have got x to the power minus 1 because x is there, so x to the power minus 1 is there. So I can simply write it down as x to the power n plus 2r minus 1 divided by this is 2 to the power n plus 2r, and then there is a 2 here. So what I can do is I can remove this from here. I can bring it down denominator plus minus 1, right? So this is nothing but minus n j n x plus I have got x. This is n minus 1. So this n plus r gets cancelled. Okay, and in here, well, I'm grabbing this and writing this again and again because you've already done it, I hope, and this is very simple. Just showing you the steps here. This can be n minus one. I believe I can write down n minus one.
N minus 1 plus R minus R plus R
Plus,
plus 1.
plus I plus one. So this is n minus one. Okay, and this one again, I can modify this accordingly. I can write it down as x by two. And this one we have done so many times. Plus 2 times of r minus. Okay. So, sorry, 2r, not a minus 1, right? There should be a minus 1 here, plus 2r. Okay. And minus 1 is already there. So, this is there. So, that means there is an n minus 1 here, there is an n minus 1 here. So, that means whatever relation we get is j n minus 1. Obviously, it's not that short, but I'm expecting that you've done some steps. I'm just, clarifying things before confused somewhere. Okay. You have to practice it once or twice, and then it will be very clear. Okay. Okay, finally, the last two recurrence relation that which you want to check. Okay, let's just do this. Okay, for the last two recurrence relation, you have to remember two recurrence relation. That's the tragedy x, k, and dash x. We have done the first recurrence relation, and we have also done one more relation here. So the first relation that we've done is n, k, n, x minus x. N plus 1 x. This was the one relation that we have done. Okay, it's not the first, sorry, I think this is third and fourth. Right? Yeah, this is the fourth one, the third one, third and fourth. Okay, so to remember these two relations. And for the next to resolve, minus n to x plus x to n minus 1. Let me mark this as number 1 and mark this as number 2. Okay. What I have to tell you here is, remember, very important, what we have to do here is to derive relation 5 and 6. So after 4 we have derived, we are going to derive relation 5 and 6. Okay. If you want to do that, it's very simple. Let me just tell you what we have to derive. The relation, fifth relation is that 2 times km dash x is equal to k n minus 1 x minus k n plus 1. If you look into it straight away, you know what exactly you're supposed to do because I've already given you a hint. 2 times j n plus x, so that means you're supposed to add it up. Okay. And then if you add it up, you're going to get this relation very simply. So on top, you've got 1 plus 2. When you write down in your exam, please mention these two recurrence relation and say we can add them up. So on the left hand side, this is 2 times of x, k, n dash x. On the right hand side, here we have got these two. These two will get cancelled out. These are added. So get cancelled out. We have got here. So what I can do is I can probably take x common, and if I take x common, I have got this relation which is k n minus 1 x, and then minus
Oh, sir.
x. Yeah.
Sir, what is the PT? Actually, some noise are coming, so I
Prove
couldn't
that.
hear.
Prove that. Shortcut is that.
Okay, 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 okay.
Okay. So this is there. So I can cancel out x on both sides. I will get 2 times k n dash x is equal to whatever is required. K n minus 1. So you don't need to do anything here. Just need to remember. That means technically you need to know 4 recurrence relation. The 5th and the 6th one can be easily derived. Okay. So this is in a similar way you can actually find out the next recurrence relation. Let me just write it down. It is 2n j n x is equal to x times k n minus 1 x plus a n plus 1 x. So that's your last one. Here, obviously, you have to subtract one from the other. Why obvious? This is 2n jnx. N is on this side. So if you take this n minus minus of n, so there will be 2n jnx. Okay? And then you do it, you're going to just subtract one from the other, you're going to get the relation. It's very simple. One is add, one is subtract. So that means you remember the fourth and the, not the fourth, third and the fourth recurrence relation. Okay? So please remember these, and using that, you can actually find out the difference.